este momento.
Thank you very much to be here. I'm going to present you Professora Jasmiska Dolta. She got his PhD in math and computer science in Zagreb University. I know her because she works right now in symbolic data analysis, some conference about symbolic data analysis. She's to talk today about emotional analysis in textual documents. Very important subject right now. It's very used, for example, to analyze political documents, etc. So thank you very much. It's good to be here in Costa Rica in the sabbatical year. Thank you very much. Go ahead.
Thank you. Thank you, Aldemar, for your introduction, and thank you for having me here. I'm here for a month, and I'm going to be another month, and it's very nice to be here. So thank you very much. So I'm currently the leader of this laboratory of generative programming and machine learning, in which we are dealing with machine learning and generative programming, as the name says, and it is on the faculty in the University of Zagreb, Faculty of Organization and Informatics. Here is the main building, so we don't have so many buildings. We are part of the Zagreb University, but we are 700 kilometers north, so we are a little bit dislocated. And so we have certain programs from the area of information science and economy, and we also have lots of students, almost 3,000 students. And we have many courses, more than 300 courses. Here you can see a few from this window. So it is the main square in Varežu. Varežu is town, about 50,000 inhabitants in the northern part of the Croatia. This is the city hall. So, and here we enjoy drinking coffee because we also like coffee to see. So today I'm going to give some introduction about psychological models of emotions, then say something about sentiment and emotion lexicons, give one example of application of one of the lexicons, and so the main part of my speak will be this method of extraction of lexicon from annotated data set, for which I use a measure of adjust measure of symbolic disorders, and I'll give a possible application of SDA, so symbolic data analysis in natural language processing, so the whole array of possible applications. So what is sentiment analysis? So sentiment analysis is classification of text based on polarity as positive, negative, or neutral. On the other side, the emotion analysis is classification of text according to emotions based on some sort of. So it can be, for example, I will mention two models which are mostly used in the area of natural language processing. So the first is Ekman's model of emotions, which was introduced in 1972. It has 6 main emotions. And the Plutchik model of emotion, which was introduced in 1980, it has 8 main emotions. So it has joy versus, they're in pairs, arranging for opposite pairs. So this is joy versus sadness, then this is anger versus fear, trust versus disgust, and surprise versus so classification can be done in supervised manner or unsupervised manner. So supervised manner is using annotated data sets, and unsupervised manner in this context usually means usage of lexicons. So why this unsupervised approach is also important, and why it is important to have lexicons. Well, we know that the meaning of emotion of the word depends on the context, but making of lexicons is very important because so labeling of documents according to emotions is very demanding task. So sentiment analysis is easy because it is easier to get data sets, to annotate data sets. There are reviews, positive, negative, but it is a little bit harder to get emotional data set on the web. So there are ways in some questions that there are that we cannot rely so much. So mainly lexicons were made in the past by psychologists, and then they were extended in some automated, some semi-automated way. So emotions are often subtle; they are context dependent, and it is hard to distinguish between emotions. Sometimes we can, in one simple sentence, we can have more than one emotion. So for the sentiment analysis, it is not like that. Usually, in one part of sentence, we can have one positive emotion and other negative, but not in the same sentence. So that's why the definition of emotions is even harder test than sentence. So, and of course, language expressing emotion varies across domains and cultures. So, sentiment lexicon is a list of lexical features. It could be words, that could be entrance, so 2 grounds, 3 grounds, and so on, of words that appear frequently together, as well as, for example, as machine learning, data science, something like that. Also, emojis are important in sentiment or emotional analysis. So, sentiment lexicon is a list of lexical features which are labeled according to their sentiment orientation. It can be positive, negative, or neutral. Emotional lexicon is a list of lexical features which is also annotated or labeled according to emotions based on some support. So, this is how I make a division of type of lexicons. It could be done based on how lexicons are created and based on how lexicon assess sentiments or emotions. So lexicons can be made manually, semi-automatically, or automatically. And based on how lexicons assess sentiment or emotions, it can be binary or it can be quantitative. Usually, it is start from 0. So, how the lexicons are created? The first lexicons in the past, they were created by psychologists. So we have these lexicons from 1966, and further we will use this NRC emotion lexicon, which was proposed 2013. It was made on the basis of the words of previous lexicon, which were manually collected, and then it was used crowdsourcing on the platform of Amazon. So these are manually generated lexicons, and we have also lexicons also can be semi-automatically generated. So they start from manually taking words, and they are extended by automatically using synonyms for Turing's networks, so graph methods, rules, and so on. The example is this lexicon Veder, which was proposed in 2014, which starts from manually annotated words, but then then extended by rules. So it uses intensifiers to label if, for example, words like very much, something like that, which stress more the word before. After, and negations. So negations are also very important because it is opposite meaning. We have negation in front of some word. Then large letters also. If we have large letters, then emotion is stronger. Should be stronger. Emojis, internet acronyms, and so on. So this lexicon data is very effective in classification, in sentiment analysis on social networks. And lexicon also can be created automatically. So approaches are corpus-based and model-based. So corpus-based is using WordNet. This is desirous of terms arranged in a set of synonyms, sort of synsets, and by some methods like point-wise photo information, appearance with seed words, and so on. And we can also automatically obtain lexicon by model-based approach using language models and embeddings. But in either case, we usually, I don't know any case where there is no seed words in the beginning. So in the beginning, you have to give some seed words, and then based on some methods, you extend that this seed words. So example is center WordNet, which is based on WordNet and semi-supervised methods. Based on how lexicons annotate sentiments or emotions, they can be binary. These are manually made. Mostly, the most frequently, these lexicons which are manually collected are binary, and those which have some which are automatically or semi-automatically generated usually are start of 0. And there is also the measurement model where words are ranked in terms of their pleasure, also in dominance. This is part of this whole. So I will show you now. So just to convince you that using a lexicon is useful, that it can give immediate results, I will show you one example, which my PhD student and I made. It's based on NRC, Word Emotion Association lexicon, which contains more than 14,000 of terms. It is annotated binary based on food models. So we have 8 emotions, and we have positive and negative sentiment. It uses Amazon mechanical Turk for annotation.
It's kind of sorry about that. I think it'll work. Yeah.
Thank you. So we have used this data set from Kaggle, really a lyric of every Eurovision song into history. So Eurovision is a song competition that is going on from 1956, and we have supplemented with lyric for Eurovision song from the 2024. So we have many songs. It has 14 attributes. We have used the attributes of the year of competition, the country of the representative, the final position, and the lyric in English language and in original language in which was sung. So first, we wanted to see if there is difference between emotions between winning and non-winning songs. We can see that these songs, which lyrics from winners, have differences positive for positive emotions mainly, and it is negative for negative emotions. So we can conclude that Winner's lyrics has more positive and less negative emotions. That could be recipe for the good song. Then we have analyzed emotions or lyrics across case. So we have analyzed from 50s to 60s, 70s, and to 2020s. We can see that anger is increasing, disgust is increasing, fear is increasing, sadness increasing, joy is very rapidly decreasing, trust is decreasing, anticipation is decreasing, surprise is so, but surprise can be positive or negative. So it looks very intuitive. I don't know what is the reason for that. Maybe we live in a more serious time, but maybe the songs are more serious. It seems intuitive. Okay, and we have also analyzed if we can get some clustering of countries based on the lyrics. And we have chosen some of the countries. So big five, this is Germany, France, Italy, Great Britain, and Spain. These are lands in countries which are directly qualified to the finals. I didn't know that exists before we were using that data set. Then to end some countries that were often winners on the competition, and we also use Croatia, Serbia, and former Yugoslavia because it was interesting to us. So we obtained mainly three clusters. This is the cluster with most positive emotions. Here is France and Luxembourg. It seems intuitive, similar mentality. And here is Israel. Israel is always on that competition. And often it was winner a few times. And we have Norway here, which doesn't seem so. So Sweden and Norman does not fit in that picture geographically. But I don't know about their mentality. Really far from us. But here we have cluster with Mediterranean, except Sweden. We have Spain and Sweden, which is not intuitive, but here we have Croatia, Italy. So Spain, Croatia, Italy, these are Mediterranean countries. Here we have Germany and Netherlands, where similar language and similar mentalities, I think. And here we have United Kingdom, Ireland, and Russia at the side. And here we have Serbia and former Yugoslavia. So it also seems intuitive to me. So the main part of my talk will be about this extraction of lexicon from annotated data set. So what is the aim of that, and what are desirable properties of the lexicon? So this lexicon will be obtained directly from the data set. So it will be corpus. It will be created without usage of seed words. So, in my opinion, in that way, we avoid bias used by seed words. So the advantage for us would be for small languages that it is domain specific and it is on the language which data set is. So extracted lexicon will assign quantitative words for every emotion, and we would like to that the dominant emotions will be assigned the largest weight, and the other emotions are penalized to in some way separate emotions to make more easily to classify emotions. So the emotional weight will be assigned to every term for each emotion, and the weights will be calculated using adjusted as discordance measure of symbolic data analysis introduced by Edwin Dide. So we assume representation of documents in the vector space model. So this is, let's say, old model. This is a global model. We have language models which are based on context, and this is model based on global usage of the terms. In the term document matrix, so documents are represented in term document matrix. Rows represent words, index terms. Usually we have a few hundred of or few thousand or a few 10 of thousands index terms, and columns represent documents. So on the EJ entry will be weight of the ith term in the J. And this representation is sparse because most of the documents contain only a few index terms, and there are lots of index terms. So usually it is used DF-IDF weighting in calculation of this weights of term in document. So this weight depends on the frequency or appearance of index term in the document. This is a local part, and depends on frequency of appearance of index term before collection of documents. This is global part. So here are formulas. The first is, so this is the local part, and this is the global part. So local part is just frequency of the term X in the document D, and the global part is logarithm of, this is the total number of documents in the collection, and n of X is number of documents in the collection that contain term X. So if the number of documents that contain term X is big, then this is small, and the global weight is. And here's another formula which was actually used in classification according to emotions, and it is often used in sentiment analysis, which instead of the frequency here is just have sign. So just we have only if the word is present in the document or not how much, how many times it was present in the document. Okay. Don't
worry.
I just wanted to delete.
I think you're
Just to delete.
no. The thing is, I think you're using actually the.
Yes, here.
Yeah. No.
Yes, here. Yeah.
No, because you're using the like the presentation, like the yeah.
Okay.
That one. So I think. So, yeah, this. Sorry.
Is it? I'm sure we cannot. I'm sure we cannot by this. No.
You're writing in the other app directly, so that's.
Y no es en el sitio este a la derecha, pero el menú.
¿En cuál menú?
En este arbolito que sale a.
Cierto, tengo la.
Claro, esos arbolitos que salen no son como el.
Okay.
It's with this one, actually.
Here.
Here.
Here. Okay.
Okay, but there's.
You want to look up.
Sorry, because I. Okay, so sorry about that.
Okay. Sorry. And so a few words about the discipline of supporting data analysis. This is discipline of data analysis that extend the standard in the data analysis to set of classes of individual entities. So classes are subset of individual entities that share some common property. So instead of analysis of transactions as one object, we can analyze all transactions done by one credit card in a certain period of time. So we can, or we can in the classical statistical analysis use analysis one analysis. We can analyze a scientific paper as one object, or any symbolic data analysis. We can analyze a scientific paper of one author, all the scientific papers of one author. Of course, we can also analyze that in classical data analysis, but when we aggregate it, then we use just mean or some measure of tendency. But in symbolic data analysis, we also care about dispersion of the data. So the symbolic variables which describe the data then are interval valued data, list distributions, histograms, and so on. I also have a little example. So here we have some scientists in Croatia, like Luka Modric, Vlašić, Toni Kukoc, and so on, and they have some works in some categories, let's say categories of Web of Science. And here we have number of citations for their papers, and here we have number of co-authors. So from that data table, we make a symbolic data table. One record for Luka Modric, which is, so category is distribution among categories, Web of Science categories, and the number of citation is interval valued variable. Number of co-authors also is interval valued variable, and here countries of co-authors, which is list. So this is one example of symbolic data table. So definition of S-discordance measure. Measure of symbolic discordance. S-discordance is based on classes described as symbolic data. It measures dissimilarity between object or class and collection of objects or classes from some partition P for a given value X of category variable X. So according to the axioms of S-discordance measured given by Edin Bide, S-discordance measure is calculated based on two functions. The first function is FC of X that measures variability between elements inside the class, and the other function is GX of C that measures variability between classes. So definition of this function. FC of X is proportion of individuals from the class for which the value of categorical variable X is equal to the X. Gx of C is number of classes C prime from the collection of classes P, for which the value of C f C prime X is in the event N E. So we have to define that. I will give an example of 4 possible events that could be interesting. So first is event E1 for characterization of classes C prime for which FC prime of X is in the neighborhood of FC of X. So it is in this interval. The another possible event is E2 for characterization of classes C prime for which FC prime of X is in this interval. So it is greater than FC of X. Then we can have event for characterization of classes C prime for which FC prime of X is lower than FC prime of X, so it's in this interval. And for the characterization of classes for which category X exists. This is the whole interval 0, 1, except 0. So, what does it mean in the context of classification of textual documents? So here, individuals will be documents of the collection. Classes will be classes of documents. So for sentiment analysis, this will be positive, negative, and neutral class. And for emotion analysis, this will be emotions according to some psychological model. So we will observe binary variables xid where m is total number of index terms, which will be defined in a way that for index term xi and document d, xi of d will be 1 if document d contains term x, and it will be 0 if document d does not contain index term xi. So definition and meaning in the context of classification of textual documents. So fc of x was proportional individuals from the class for which the value of categorical variable x is equal to the x. Meaning in this context is that fc of x is proportional documents in class C that contain index terms. Gx of C is number of classes C prime for which from collection of classes P for which the value fc prime of x is in the event E2. We will do with E2 because we will use E2 for our application. So Gx of C is number of classes C prime from the collection of classes P for which the proportion of documents from the class C prime that contain term x is greater than that proportion of the class C. So we will use this function for penalization. If there is classes, so we will count number of classes for which proportion of documents that contain term x is greater than for our observed class. So these are selected measures of this of S discordance. I have used this one, but similar results for with the other measures. So I have used this one, and it will be used event E2 for the characterization for definition of function Gx of C, because we are interested in to do penalization by number of classes which have high percentage of documents that contain. And we will correct the original definition of the function fc of x because we have many classes. So this is specific situation in this situation. We have as many not many classes, but we have many categories. Category 6. We should have as many categories as there are index terms. So original function fc of x is calculated in a way as n x of c, where n is number of documents in the class C in which term x appears, and divided by nc, where nc is total number of documents in class C. So in order to avoid high asymmetrical distribution and assignment of high weights to the terms with low global weight, we will correct this function in a way that we will define hc of x as nx of x is C. So this is the total number of documents that contain term x in the class C, and we will divide it by total number of documents that contain term x. So the emotional weight of the term will be defined as a measure of symbolic discordance, but with that corrected function. So hc of x is proportion of documents in collection containing term x that belong to class C. And G is defined analogously using that function. So the relevance of term x for the class C. So index term x will be characteristic for the class C if the value of function h is high, meaning that the high proportion of documents belonging to the class C among all documents that contain. There is lots of documents in class C among all documents that contain that term, and the value of the function g is low, meaning that the number of classes C prime for which the proportion of documents containing term x higher than in class C is small. So experiments. For experiments, we will use mainly this ISER data set. It is International Survey of Emotions and Ascendants and Versions. So we wanted to use data sets which were annotated by psychology, which are not automatically generated from the data sets. So this is one data set which was obtained as a result of project of psychologists. So it was worldwide, and the respondent were asked to explain situation in which they felt one of the basic emotions according with this. So it was one sentence or two sentences for this question. And here are 7,666 samples. So each responder generated seven samples, one for each emotion. And the other data set that it was used, it's movie rating sentiment analysis. It's for sentiment analysis, not emotion, but sentiment analysis. It contains almost 40,000 of movie reviews, and labels positive or negative. So here words with largest positive and negative weights in this example of sentiment analysis, and we can see that that it is quite intuitive that this positive and negative terms are separated in a good way. So usually words can be positive and negative. So the idea was here to separate. And here the results from ISER data set. So here data is divided in train and test set in the ratio 4:1. Pre-processing was done by transformation of letters to lowercase, removal of stop words, these are words that don't have discriminate meaning, then removal of numbers, and lemmatization or mapping of words to their basic form. So final list of index terms contained almost 6,000 index terms, and for supervised classification, it was used logistic regression. Logistic regression gives good results for text. In the beginning, it was it was mostly used support vector machines, but after that, it was shown that logistic regression can be as good as support vector machines in this application with the high dimensional data. This is without permanence. And here we have results. So for unsupervised with extracted lexicon, we get accuracy at 52.64%, which is worse than supervised regression, but usually classification with unsupervised is usually are lower results of lower measures than supervised. And we have a hybrid model which can improve a little bit results, but not much. And we have also used unsupervised approach with extracted lexicon and NRC lexicon and it was not much better by using both lexicon. We could not do with just with NRC lexicon because lots of documents were not annotated at all because there are no terms from NRC lexicon. So here a correlation between vectors of emotions in NRC lexicon. We can see that joy, these are just emotions which are in intersection of emotion for ISER data set. And we can see that the joy is not correlated with other emotions, but these negative emotions, disgust, sadness, anger, and fear, are very correlated. On the other side, here we have vectors of emotions for ISER, for lexicon extracted from the ISER data set. and we can see that all correlations are a little bit negative. I'm not very happy because they are a little bit negative. This work is in process. So I have applied E2 event. Maybe it should be applied also event E1 based on the negative, but we'll see. My idea is to correct that, to obtain the correlations very close to zero. So this method is yet to be tested. So for extraction of lexicon from multiple data sets and then application to another with transfer learning, for labeling data set with for semantic and emotional classification using language models, and to compare that to human annotators, and of course to compare it with other methods for automatic lexical extraction. But we could also use it as a first step for human annotation, which could be useful, especially for low resource languages, as is Croatian, for example. And the last topic is possible application of symbolic data analysis in natural language processing. So I will present you one research that I've done with my master student, one master's degree, and then I will explain what could be application of symbolic data analysis in this context. So we were interested in are the emotions encoded in embeddings of language models. So language model learned representation of words. So these word representations, words are represented in the vectors of high dimension. Let's say 300 or 700, something like that, 1000. So the aim was to research to see if we can association of word to emotion be learned from the lexicon. And we have used the NRC lexicon for that. So classes here are imbalanced. We have less than 10% of positive elements for each emotion. It is for anger we have more than 9%, but for some other here, for surprise, we have less than 5%. So these classes are imbalanced, and here we have done a classification in a binary mode. So one emotion versus all other emotions. We have used two language models, so word-to-back, continuous back words, word-to-back skipgram, which was proposed in 2013, and by BERT. So this is bidirectional encoder representations from transformers, which was proposed in 2019, and it shows strong performance across many NLP tasks. So in the case of word-to-vector, we have two models. So in this model, model is learning representation of a word based on the context. In this case of skipgram, it is in a way that that based on the target words, it is predicted contextual words. And in the case of the continuous back of words, based on the context, it is predicted the target. And the BERT is transformer-based model that uses multi-head attention, so it is dimension is much higher here, and it's a neural model which has strong performance for many NLP tasks. So here are a few facts about design of experiment training. So it was trained model works to back. Both models were trained using emotional data sets. Dataset number of epochs were chosen in these are hyperparameters that were optimized, and training time was approximately 3 minutes. And we have also used BERT. We have fine-tuned it by the same data set, and the training time was 7 hours in this case. So classification is performed separately for each emotion and trained by bidirectional long short-term memory network and evaluated on 5-fold cross-validation. So here are the results. So these results of F1 measure are not very good, but they are not bad if we take into account that the sets were very imbalanced. I think we should repeat the experiments with the data sets. But what is here important that BERT shows lower results of F1 measure than this much older model. So why is that so? Do you maybe know what could be problem here? So we have 2 kinds of word representation. This first models for Quebec make static word representation. So there is only one representation, fixed representation here, and this representation ignores contextual variation. That's why it is more stable in representing emotion. But in the case of the BERT, we have contextual representations, which are now predominantly used. And in that case, representations, there is a different representation for each word based on the context. So the representation is function of the whole sentence. So BERT is just not optimized for capturing the global semantic structure of the vocabulary. So here the results of recognition of emotional sentences. These experiments with the ESA data sets. So we have better results with BERT here. These are results of accuracy and F1 of there's 3 measures, and but we can also see that these results are not very good. So this task of emotion classification is hard task. So these results are, I don't know, 4 or 5%, 4% better than with that older model. But here with the BERT, we had trained model for 7 hours. So these results are lower than this language models. They need very, very large data sets, and this data set, which is annotated by the humans, is obviously too small for that models. So the idea is that my idea, but also in the literature, there is people notice that for recognition of emotion, it could be beneficial to take into account both models, the older model and the language models, because it is useful to extract some emotion, to extract some meaning, semantic from the global use of the terms in both. And so the further research will be focused on contextual embodied distribution, semantic meaningfulness, and so on. These are terms that appear in the literature, but nobody tried to use the symbolic data analysis for analyzing these categories. And I think the symbolic data analysis is would be very useful in that because we have category of representation for just one word. It would be interesting to see how this representation, this category, which could be observed as one object in symbolic data analysis, how is this category? Are the representations of the same word in different contexts closer than to another word, for example? Or, for example, if we had before a PhD student that was dealing with recognition of a patent clause, or it could be recognition of service, and this are hard tasks. So we can observe if the word is used as a metaphor or in literate meaning, how does this representation differs? There are many tests that could be, this could be the whole area for representation using symbolic data analysis because symbolic data analysis has all tools for analysis. That is what I wanted. These are the references. Thank you for attention.
Any questions? Are there any questions in the Zoom?
So that can you try these models on different languages other than English? Do the results?
So far, I've read only on the English language, but yeah, the idea is also to try to configure and to compare. But this is the main. The idea of this making lexicon is to be able to extract lexicon for all source languages as is Croatian. That is what we with that.
Then for Eurovision, did you translate it?
Yeah. We were working with the English versions, but we were using the original and English, but that was not on there. But the NFC lexicon has machine translated. Is the machine translated for 104 languages. But incorporation is validated. That the translation is validated, and it's a little bit better. Machine translated, of course.
More questions? I have a question that maybe you said it, maybe I got lost in it. How did you measure the accuracy of the models?
Which model?
Of your applications in all these BERT and
this was for ISER data set. This accuracy was for BERT was 63% accuracy. So it is not very high. These results are for the older model was 59%.
Yeah, my question is to what model is this being compared to in terms of accuracy? Sure.
Well, there is much work to do, but surely with this unsupervised approach give us lower results than supervised. But this is expected. We are trying to use lexicon when we don't have annotated data sets, so it is to extract lexicon. And of course, it would be beneficial to, for example, if we want to obtain annotated data set, then to annotate it with lexicons and then give it to humans because it will be much easier in that way.
Are there any more questions? Sorry.
It's not very clear to me, like how you measure the accuracy, like because you use large data sets. Like you create a small from the data set, check manually for the accuracy and then.
No, I have done it on the whole data set, it's not so big, it's 7,000, less than 8,000 some documents. I did it on the whole data set.
But how did you check if the models did it right or wrong?
So the data set is annotated. I have to write answers. But I have divided the data set in so 80% for the training and 20% was for testing, and this test those ones also have
there any more questions or in the chat? No?
No.
Okay, so we thank Justin again. So for the next section, las próximas sesiones vamos a tener, bueno, no sé en el, perdón, sí lo sé, para el coloquio, para el coloquio vamos a tener un profesor invitado de Portugal, Kenner Castillo, que va a dar un mini curso. El primer coloquio va a ser entonces una introducción al mini curso y esto. Y para la última sesión del seminario de este semestre va a ser el director Alberto Dales, que nos va a dar eso. Okay. Entonces ahí les estaremos avisando de esos. Y muchas gracias a todos de nuevo. And thank you again, Justinka. And see you. Sí, hay que acabar. Gracias.